The Standard Model is the best explanation we have for the most fundamental particles of matter and forces in the universe. The up quark, down quark, and electron makes up the atom. These bosons here are what we call force carriers, meaning they are particles that help mediate the fundamental forces besides gravity, which governs how everything interacts in the universe. But wait, what exactly is a particle? According to quantum field theory, particles are the smallest vibrations or excitations of a quantum field. For instance, the electron is an excitation in the electron field. Fields prefer to be in the lowest energy state, and for all of these fields, this makes the vacuum expectation value, VEV, also zero. This means they shouldn't have mass. But what is mass? This is the extended version of an all too familiar equation, where essentially it shows how energy, momentum, and mass are all related. For a particle to have no mass, it needs to be traveling at the speed of light, but clearly this is not the case for all particles, or else we wouldn't even be here right now. So what's going on? First, let's acknowledge how important symmetry is for the world to work the way it is. However, this concept also poses a problem. Particles will be massless. Okay, it's time to start talking about the Higgs field. Firstly, it's symmetrical, but secondly, it has more than one lowest energy state where the VEV is non-zero, which means the field has an intrinsic mass. Let's say this ball is the Higgs field and the hat is the 3D representation of the previous graph. It starts off in a symmetrical state, but shortly after the Big Bang, it falls to one of the lowest energy states, and the symmetry spontaneously breaks. And as you may have guessed, the Higgs boson is an excitation of the Higgs field, its force carrier particle. The other particles gain intrinsic mass by interacting or coupling with the Higgs field via the Higgs boson, which stops it from going at the speed of light. Massless particles, like photons, don't interact with the Higgs field, so can continue traveling at the speed of light.